Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our fifth lecture on design of transmission lines and distribution lines. The previous lectures are available on my YouTube channel. I will show you my YouTube channel. This is my YouTube channel. Here you can go to the playlist. On clicking the playlist, you will see here there is a playlist on the name of design of transmission lines and distribution lines. When you click on view playlist, you will find all the lectures here. Other playlists are also available here, like selection of cable sizing and voltage drop, electrical interview questions, short circuit analysis, etc. Now, today's lecture is about the sag. What is sag? How to calculate tension on conductor? How to calculate sag of transmission line? Here we can take an example and calculate the sag of a transmission line and calculate the tension on a conductor. This can be used in a practically how we can calculate the sag and tension on a conductor in a practical on a ground field on a field, how we can calculate these things. First of all, what is sag? Sag in overhead transmission line refers to the vertical distance between the lowest point of a conductor and the highest point of a supporting structure, that is poles or towers. The highest point of the structure is this and the lowest point of the conductor is this. The distance between these two is called the sag. Sag of a conductor cannot be avoided. It occurs due to weight of conductor. This sag cannot be avoided because conductor has always a weight, and due to the weight the sag occurs. Excessive sag can lead decrease in ground of a transmission line, ground clearance of the transmission line. This is the ground clearance. This is the ground clearance. With the excessive sag, the ground clearance of the transmission line gets decreased. Sag has some importance to reduce the conductor tension due to expansion and contraction of conductor during increase and decrease of temperature and wind, etc. At that time, the sag reduces the tension on the conductor. What are the factors on which the sag depends? Number one is tension of a conductor. Sag is inversely proportional to the conductor tension. That means if the conductor tension is less, sag will be more. If the conductor tension is more, sag will be less. Weight of conductor. Sag is directly proportional to the weight of conductor. Temperature. Sag is directly proportional to temperature. With the increase of temperature, sag increases. With the decrease of temperature, sag decreases. Wind and ice. Wind and ice exerts additional force and load on the conductor, thus affects the sag of a transmission line. Sag calculation. Now, how we can calculate the sag of a conductor? There are two calculations. One is sag calculation for equal heights, when the supporting structures are at equal heights, they are on the plane ground. Second, sag calculation for unequal heights, when the supporting structures are at unequal heights. One, that is when the two supporting structures are at unequal heights from the ground level. First of all, I will take the sag calculation for equal heights. The formula for that is S is equal to, that is the sag, WL square divided by 8T, where L is span length in meters, W is weight of conductor in kg per meter, and T is the tension on the conductor in kgs per meter. We can take this example. Calculate the sag of a transmission line of rubber conductor having span length of 25 meters, wind pressure is 75 kg per meter square, and ice thickness is 12 mm. Step 1. This is the data here. This is the data which we had taken from the Example, span length is 25 meter, wind pressure is 75 kgs per meter square, and ice thickness is 12 mm. In setup 1, tensile strength of a rapid conductor as per IS 398-1961 is 1860 kgs per meter. This is as per the IS tension strength of a rapid conductor. Conductor tension equals 0.35 into tensile strength of the rapid conductor, that is 1860, that becomes 651 kgs per meter. Setup 2, weight of conductor is 0.213 kgs per meter as per the IS 398 to 1961. Diameter of conductor is 10.05 mm as per IS 398 and dash 1961. Setup 3rd, wind load is equal to 0.667 into diameter of a conductor in meters and wind pressure, that is equal to 0.667 into 10.5 divided by 1000 into 75, that becomes 0.502 kgs per meter. Setup 4, ice loading is equal to WI is equal to 0.0028 into T into D plus T into T, that is equal to 0.0028 into 10.505 plus 12 into 12. Here the diameter is taken mm, is becomes 0.741 kgs per meter. Now we have calculated the wind load and ice load. In setup 5, these are the data taken from the calculation, and this is the data taken from the example. Ice load, wind load, weight of conductor and conductor tension, and this is the span in meters, that is 25 meters, wind pressure, ice thickness. All these data is taken from there because this data is used in our calculations. Resultant weight is equal to under root of W plus WC plus WI square plus WW square is equal to 0.213, that is the weight of conductor, 0.213, WI, that is weight of ice loading, that is 0.741 plus WW, that is the weight of the conductor, that is 0.0, that is 0.502 kgs. Putting these values in here in this equation, it becomes 1.078 kgs per meter. In setup 6, S is equal to WL square divided by 8T. W is 1.078, which we have earlier calculated, into 25 square. Length of the span in meters here is 25 meters square, divided by 8 into 651. T is the tension on conductor, that is 651. It becomes 0.52 meters. This is the sag of the rapid conductor of span 25 meters is 0.2552 meters. Now in the next lecture, we will calculate the sag of a transmission line at unequal heights. Thank you.